All right, so I want you to be on the side that's like a full page. It says AP Stat, errors, power, p-value. So we have talked about p-value a little bit. When I draw a picture, what is p-value? I wouldn't, because I would use the calculator. If I draw a picture, where is the p-value? What is the p-value? The area that is shaded. So we've talked about it, we get what it is, but we haven't really written a sentence for it. So everything that we do is hypothetically under the scenario, assuming that what? The null hypothesis is true. So it is very important that it is, if the null hypothesis is true. So if the null hypothesis is true, is the likelihood of our sample data occurring essentially? Then there is a p-value % chance of having a sample just like we've dealt with so many times, only of this sample size from these individuals. And hopefully y'all have more than me because y'all have a full page. So I'm going to go super hypothetical and give you kind of like a fill in the blank thing, but we're not going to write it. So finish writing that first. Farther. So don't write what I'm writing. Let's pretend I'm dealing with something like given the null hypothesis that I'm dealing with a B student. Probability that they're getting better than a B. And I get something like so what % chance is that? So if this person really is a B student, there's about a 2, and so like let's say I took 3 of their tests and found the mean of 3 of their tests. So if they really are a B student, there's about a 2% chance of having a sample of 3 test grades with a mean of whatever number we got, 95 or whatever, with a mean of, let's say their average is 95, of a 95 or higher. So the likelihood of them actually being a B student, or them being greater than a B student, would be about 2% likely, which means I have a lot of evidence against this, which means maybe it's not the case that they're a B student. Do I need to say that again because I kind of mixed up in between? So let's pretend we took 3 tests. So if they really are a B student, there's about a 2% chance of having a sample of 3 tests with a mean of 95 or higher for that student, which means that's a lot of evidence against this, which means you would overturn it. That's not very likely that a B student would have an average of 95. Basically, is what that's saying. Which means maybe that's really not a B student.
They're a B student?
Huh?
Wouldn't they only be able to get 95% of the time they get true zero?
No, so this by chance would occur 2% of the time if they really were a B student. So, but that did happen, and that's very unlikely. So maybe they actually weren't a B student, and that's what happened.
You lost.
Right? Without numbers. I'm making a distribution for a B student. So if I were a B student, the likelihood of me actually having an average of 95 is really, really unlikely. So maybe I didn't come from that distribution in the first place. That's the whole process of that saying. So, continue with what we're actually saying right now. So, what is the idea of what we're checking with p-value? To see if the probability of our statistic occurring is, what do I actually compare p-value to? In a problem, what do I actually compare p-value to? Alpha. And I want to see if it is what? Less than alpha. And so this is what I mean by really unlikely to have actually happened. So if it's so unlikely to have just happened by chance, then maybe I'm drawing the wrong distribution in the first place. So statistically significant is kind of continuing on that. If the likelihood of our value or our event, our statistic, is so unlikely that it doesn't seem to be just variation due to chance. So if the likelihood of our value occurring is so unlikely that it doesn't actually seem to be just variation due to chance. Which is evidence towards what? And all this is doing is saying p-value less than alpha. So if your p-value is less than alpha, then it is statistically significant. So this is what we've done. I just hadn't used that term until today. So when we reject the null hypothesis, it's statistically significant. But this is like the idea behind it, why. So if I ever ask you, is this statistically significant? And that's all that I ask you. If I give you this scenario and say, is this statistically significant and why? For that one, is your answer yes or no? Why? Yes is correct. P-value is less than alpha. I always have people who think they need to do a lot more than that. So is this statistically significant? Yes. Why? Because p-value is less than alpha. if I ask you what statistically significant means, this is what I would be asking about.